This is lecture 15, example 1, and we're going to do an example problem. This is a big timing diagram example. Lots of signals in it, more than what we've been doing before. Very big problem, very important, a lot of stuff going on, and I want to impress upon you that, hey, I don't know this stuff off the top of my head. I'm working off my cheat sheets sitting in front of me, and so this is a course where there's so much material. You're not required to, quote, know it. Part of the course is you have to be able to figure things out, which means you have to be able to know how to use the cheat sheets and the spec and that type of thing. So I have the cheat sheet sitting in front of me, and that's what I'm going to use to do this problem. Okay, so let's go ahead and do this. And it's a programming problem. And it's a little bit different because I'm going to execute that instruction as I do this right. This is the program we're going to execute, and it's a little bit different because it does have a conditional jump in there, which I don't really know in advance what's happening with that. It's going to be some special value, but I know I'll execute this instruction followed by this instruction. This is a jump, so it jumps down to here. That'll be the third instruction, and this will be the fourth instruction. And after that, I'm not sure what it does. We'll have to figure that out when we get there. And so initially, we've got some initial conditions here. I've got the program sitting here. I've got it written on a separate piece of paper that you can hear it rustling over here. You should do the same thing. And the issue is that there's just not enough room on these things. So let's go ahead and try to do this thing. Okay, and here we go. First instruction, I'm reading it off my cheat sheet here, is this SLT X20. Okay, barely fit in there. That's followed by a JAL. Dog, and that jumps down to a load word. X8, 0, X11. That's good. We got some extra space in there. That's a 3 cycle instructions. That's good. Then I'm going to come over here. This is going to be the next instruction. This is BG branch greater than X8. I'm going to make that smaller. Maybe I can actually fit it in there. X8, X13, done. And that's followed by something that we don't know yet. So this is going to be a fetch. This is going to be execute. Fetch, execute, fetch, execute. Then we have a write back in there. This is going to be a fetch and an execute. And well, that's it. There's certainly no more load instructions, so we can actually say that's going to be fetch, execute, fetch, execute. And that's going to help us do the next instruction here, which is the PC. Now, PC value on this one, I don't know what the PC is, but it does start at cat, and cat is given as 50, and so that's going to be 0x50. Trying to control this pen. This is going to be the next address, which is 0x54. And then I'm looking at this thing, it's going to jump to dog, and the address of dog is at 5C. It actually skips 58, so 0x5C, looking good. That's going to be a 3 cycle instruction. This one is going to be 0x60, and that's about all I can do because I'm not sure if it's going to take that branch or not. So I'm going to leave that at that. So PC right here, normal signal, it's always going to assert at the last the last state in any instruction, which means for these instructions it's going to be the execute state. Yet for this write back instruction, for this load instruction, it's going to be the write back state. And for every other instruction, it's going to be execute state. Even though I don't know what those instructions are, I know what the PC is doing. Okay, so I handled that pretty good. And so let's look at, I don't know, we just step through this thing. So let's look at reg write here. This is an SLT instruction, so a register is going to be written. As a result, one of the registers is X or 0. And JAL instruction, super important. This is not very, you have to check the spec for this one. I know from doing these is what this is doing. It is going to, it's part of the JAL, write PC plus 4 to a register. Okay, so the register based on this instruction is X1. So we're going to put, it's going to write that register. Okay, looking good there. And then this is a load instruction. It is going to load a value from memory into a register, but it ain't going to do it until it has the value, which is in the write back cycle. Okay, and then what we have here, BGT instruction. I know for sure BGT is not going to write anything, and I think I'll stop there. I don't know what the other instructions are doing. Okay, so now we're at memory read, memory write here, and none of these instructions in this whole program write memory, and so I can just fill this in. It feels good to get a complete row done on this thing. Okay, so memory read is this memory read 1 is for the program memory, and so it's going to assert every single fetch cycle. And that's a given, and so I can fill this in. Okay, so I have a jog there till the next fetch cycle. Even though I don't know what these instructions are, I know the program memory it has to be read at that time, so it gets turned on. Okay, so memory read enable 2. I'm trying to think of I have to read something from memory here. This is actually data memory. Most of these instructions don't do anything with memory. I'm trying to think of what the last instructions. I can see the last instructions, whatever goes over here, it doesn't do anything with memory either. And so the only time I do anything with memory is in this execute cycle of the load instruction. So what it's doing is loading something from memory, so it has to assert the memory read on that thing, and I'm going to do it right in the turn it on in the execute cycle for that. And so the result is the effective address is going to be put together by adding something with the accumulator or with the ALU blah blah blah, and that address is going to be sitting on memory at the memory address input, and then I simply have to read it. So very quickly, I've made a lot of progress into this thing, and without too much effort. Okay, so let's keep going on this. I think we can do the ALU function here. So it's always, we never know what it is here. It's because it's based on the last instruction, but this is SLT, the set if less than. It almost sounds like a compare, like it should be done with another register, but it's not. I actually have to pull my cheat sheet out here. I'm looking at my cheat sheet. I'm actually looking at the schematic because there's the ALU operations on it, and this is going to be, for this SLT, it's going to be 0010. And that, once again, this came right off the the schematic diagram. Okay, so that looks good. Okay, so the jump in the link is, it has essentially nothing to do with ALU, so I don't need to worry about that. And this is a we'll call it DC for don't care. And here we are at the load instruction. A load instruction has to add the offset plus the base register right up here. So I know For those 3 cycles, this is going to be an add for the ALU function, which is, I think I have that memorized, 0000. It's a good guess. And then for this compare function, I still don't know whether I'm jumping or not, but I do know that the compare is done with other hardware. It's unlike this set of less than. It's actually going to be don't care. It doesn't use the ALU. So right away, anytime I'm not using ALU, I can get rid of these things, because these ALU source signals are certainly are not used. DC. Okay, we're getting there. DC for don't care. Okay, looking good. So these are, might as well fill these in. Okay, looking good. Okay, so ALU source A for the SLT is going to be, I have to choose a register. Remember, this is comparing 2 registers, and the compare is done in the ALU, so I have to turn that off. I know source B is going to have to choose the 00 input, which is the RS2 output of the reg file. Looking good. And so I can just put that 00 in there. 00. It's a normal instruction. It's not doing anything fancy like a jump or anything like that. So my PC source is going to be also 00. Let me check that for 00. Okay, so remember, it's going to choose the 0 input of the PC source. And the RFWR select is going to choose the result of the ALU, which is going to be, of course, 1, 1. This is the 3 input of the reg file mux. Okay, and looking good. PC source, these are, this is special now. This is the JAL instruction, which means I have to choose the JAL input for the PC source, which is 3. Okay, so this is at the PC mux. It's a JAL instruction. I'm choosing the JAL input, which is 3. Okay, the RFWR select is, remember, it's writing X1 as part of this instruction. So I need to save the PC. The PC is the 0 input, the 00 input. It's actually it's a 4 input mux. So that chooses the PC output to be written to the reg file. Okay, looking good. Okay, so what else we got here? This ALU source A and B for the load instruction. So let's got to figure this out. So a load is an I-type instruction. So I know it's going to choose 0 for RS1, and B is going to choose the I-type, which is 0, 1. Okay, so this is the lower mux. I know that because the load is an I-type instruction, so it's going to choose that I-type input, which is the 0, 1 input on the lower ALU mux. PC source, this is just a normal instruction, so I'm back to 0, 0. And so what else do we have here? RFWR select. Okay, so this is a load word. Now this data is coming out of memory, and it's going to go into a register, and that means I have to route that D-out2 output from memory into a register, and it looks like it connects to the I'm looking at the cheat sheet now. It connects to the 1, 0 input of that mux, so that's going to allow me to get D-out2 into the reg file. Okay. Well, look, we're almost there. We're actually at this instruction now, and we get to figure out what's in these registers. So, what do I have here? I have X8, and X13. So X13 was given. X13 is CC, and X8 is, what's X8? Well, it turns out that this instruction is a input instruction. I know that because X11 happens to be the address. What is the address? It's given somewhere here. The address 0x11001100, which is greater than 0000FFFF. And so it's doing an input. What it's inputting is the value on the I/O bus, which is given as part of the problem as 0xFF. And I'm going to try not to mess this up. That never changes for this problem. Looking good. So X8 has FF, X13 has C. So it says branch if greater than to done. Done is the JALR instruction. It jumps over the XOR. So this is the JALR X1. Okay, and after that, the next instruction is AND immediate X8 X8 0 F. Kind of ran out of room again. Okay, so we're done with the instructions here. So what we need here is on this branch. The branch is taken, which means for the PC source I have to choose the branch input, which is 1 0. The branch is going to be taken. This signal, this PC source, is coming out of the control unit decoder, which has essentially the output of the compare. This branch condition generator does the compares. It's another hardware module that we haven't talked about yet. Essentially, it's just a comparator. It does the compare. And it does compare. The decoder decodes it, sends out the right PC signal. So it's either going to be 0 0 or 1 0. In this case, because X8 was greater than X13, it's going to be 1 0. It's going to take the branch. Okay, so on this one, it's going to be RFWR select. Certainly, I'm not writing anything to the register. You can see it right there. So this here is a don't care. Okay, God, we're getting there. So JALR, we've kind of seen that before. We're ready to do it. I just fill these in. Okay, so JALR, reg write. It is JALR. So I have to write. I'm writing that PC blah 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 address. I know I'm going to do a reg write on this thing, and the end I is also going to do a reg write. So if look at that, we finished that, and the next instruction is going to be yes. So the issue is this is it's very confusing. Jumping link register is a return from interrupt. That's typically how it's used, and so the issue is that it's taking what's in X1 and essentially it's loading that into the program counter. So it does sound kind of strange, definitely. But the issue is the question is what's in X1? Well, it turns out what's in X1 was put in there by this instruction. So this instruction right here loaded PC plus 4 into X1, so the address of this instruction is going to be 0x58. Now that's totally weird, and so this one is wrong. It is the end I, but it's the end I at 0xF8, so it's X10, X8, 0F. Okay, so I've got to barely fit that in there again. Okay, so that was really trying. So once again, this JAL is jump and link register. The link register is X1. X1 got filled by this instruction. I don't know, it's super confusing. You know, it threw me for a loop also. And so the issue is with this instruction is this is another instruction here that the jump and link, it doesn't use the ALU, so these are don't cares. And so what else do we got here? The PC source is now associated with jump and link register. Looking at my cheat sheet here, that's the mux in front of the PC, which happens to be mux in front of the PC, which happens to be jumping link register 01. Okay, and the RFWR select, I know this is turned on because it's writing the PC again. So this is 00. Might as well go ahead and finish this. So ALU fun, this is function here is it's doing an AND instruction. So I pulled that right off the schematic. ALU source A is going to be well, it's not going to be that. It's just a signal here. It's just going to be 0. It's not a bus. ALU source B, it's an immediate type instruction, so I'm going to choose the I-type input for the lower mux, which is a 0, 1. And the PC source, just as we're back into normal operation here. And lastly, RFWR, the select is back kind of normal operation. It's going to select the result of the ALU. Okay, so look, you know, that was tough, but we did it. So we're almost there. Let's go ahead and fill these in. So these are I don't knows. And then we got some interesting information coming out of these things. So this WD signal is what's being fed into the register, and for that first value here, it got fed in a 1, which is, you know, the LSB of the 32 bits of a 1, and so that's the one we're looking for. The two sources of these things were the two registers, which I don't know what they are, but we'll go look at them. It's X10 and X13, so it's AA and CC, which is hex, and that looks good. So we crank through that one. So the next thing here is once again this JAL instruction. Maybe we should have done this first. Is that it's writing something to a register, and the thing it's writing is X1 by default, and the thing it's writing is 58. So this 58 is this 58 right up here. That's where that came from. So the other two registers here, it's not using the ALU on this thing, so these are don't cares. Wow, we're getting there. We're almost done with this thing. Gnarly problem. Okay, and now we are at the load instruction. So what I'm going to do here is what am I going to do on this thing? I need to do a couple things. I need to write something to a register. Now this is an input instruction, so it's inputting something to a register. That thing it's inputting is not really known until this other part right here, once I get some type of address. So once I have the address, I know it's going to be input, and the thing it's going to be input is 0xFF, which is this signal right here. Remember, we're doing input. We're not doing a write operation. And so RS1, what we have here is these two have to represent these two signals. The immediate value is RS2, which is 0, and the other value is essentially the base address, which is 0x1111. Oh, get that right. 11001100. Okay. My God, we're getting here. I think we're done with that. Next thing we're off into is a branch instruction. Branch instruction. We're not using the ALU. We don't need to write anything, and so this is going to be a don't care. The branch instructions don't use the reg file. Certainly for this instruction here, I am doing a compare. It's actually outputting the two compare values from the register. And it's these two values right here, so x8 and x13. x8 is 0xff, which is the thing I input. The other one is 0xcc, which was which is what was 0x13, which is given in the problem. It was given in the problem. Okay, so we're almost done. Next we have the JALR, and the JALR is what are we going to do in that one? JALR. This is another instruction. What that for the register? It's going to write. It's going to write something. The thing it's going to write is the PC plus 4. So PC plus 4 on this thing is going to be 68 plus 4, 0x6c. Looking good. And then remember, that's part of the JL instruction. I'm saving the PC plus 4. And then we can look at these two things. I don't know what they are yet. So RS2 and RS1. The JALR instruction is RS1 is actually going to be, it's a JALR, so it's actually outputting a register. The value it's outputting is 0x58, because that's what's going to be actually loaded into the PC up here again. And the other instruction here is essentially, it's not instruction. The other output of the reg file is essentially not used. Wow, hard problem. The world's longest problem here is almost 30 minutes long. Okay, so lastly here, we're almost done. Reg file, what I'm going to do here is I'm ANDing x10 and x8. I'm going to check that with F. So x8 in it has FF. I'm just clearing off the top F. So this is going to be 0x0F is what gets written. And then what the two sources are 0xff and 0x0f. Okay, so this 0f here is this one right there, and I am going to call this done. Possibly the gnarliest problem in the world. You know, if you can do this, you are an expert at it. This is something that you should go over many times just until you understand everything with it. You know, the idea is, you know, I make mistakes on this too. It's very confusing, but I rely on the cheat sheets, which I have sitting in front of me, particularly the schematic. Now, the key here is I'm not super familiar with the JAL and JALR instructions because I don't use them. I use pseudo instructions instead. And so when I see those instructions, I have to look very carefully at the spec. Whew.